Let us move to the modern periodic table. In 1913, Henry Moseley, an English physicist, discovered that atomic number is the most fundamental property of an element and not its atomic mass. Atomic number Z of an element is the number of protons in the nucleus of the atom. It also represents number of electrons present in the outer shells. This discovery changed the whole perspective about elements and their properties. Thus, modern periodic law states that the chemical and physical properties of elements are periodic function of their atomic numbers. Modern periodic table has many versions, but the most popular among them is long form of modern periodic table. Let us try to answer some questions. Question 1. How are isotopes of different elements placed in modern periodic table? Answer. Elements are arranged on the basis of atomic number in modern periodic table. Isotopes have same atomic number, hence placed in the same slot. For example, chlorine has one place despite two isotopes. Question 2. What should be the position of hydrogen in modern periodic table? Why? Answer. Hydrogen should be placed at the top of the group 1 above alkali metals, as its electronic configuration is similar to alkali metals. Due to the small size of atom, hydrogen's properties are different from alkali metals. Hence, it is placed separately at the head of the table. Question 3. Write name, symbol, and electronic configuration of first 10 elements. Answer. The electronic configuration of first 10 elements can be seen on the screen. The first column gives name of the element, second gives symbol, and last column gives the electronic configuration of each element. Position of elements in modern periodic table. The horizontal rows in the modern periodic table are called as periods, and the vertical columns are called as groups. The modern periodic table consists of 7 periods and 18 groups. Periods are numbered from 1 to 7. Elements present in the same period have same number of shells, which is equal to the period number. For example, hydrogen in first period has 1 shell. All elements of second period have 2 shells. For example, nitrogen. In each period, a new shell starts filling up. The period number is also the number of shell which starts filling up in it. The number of elements present in each period is equal to number of electrons present in each shell, given by the formula 2n square, where n is shell number. You can see in table that first period has 2 elements, as K shell has 2 electrons. L shell has 8 electrons, so second period has 8 elements. M shell has 18 electrons, but outermost shell can have only 8 electrons. Hence, there are 8 elements in third periods. 2n square rule is limited to first 3 periods. The first period is shortest period containing only 2 elements. Second and third periods are called as short periods and contain 8 elements each. Fourth and fifth periods are long periods and contain 18 elements each. Sixth period is the longest period and contains 32 elements in it. Seventh period is an incomplete period. Groups are numbered from 1 to 18. Elements having same number of valence electrons or having same outer electronic configuration are present in the same group. For example, in group 1, all elements have one valence electron. Electronic configuration of lithium is 2,1 and sodium is 2,8,1. Elements present in the same group show same chemical properties. Group 1 contains alkali metals. Group 2 contains alkaline earth metals. Group 17 contains halogens. Group 18 contains inert gases. Metals are present on the left-hand side of the periodic table, whereas non-metals are present on the right-hand side of the periodic table. Elements present in group 1 and 2 on the left side and 13 to 17 on the right side of the periodic table are called normal elements. Their one outermost shell is incomplete. Elements present in groups 3 to 12 in the middle of the periodic table are called as transition elements. Their two outermost shells are incomplete. Group 18 on the extreme right of the periodic table contains inert gases. Their outermost shell contains 8 electrons. Elements placed at the bottom of the periodic table are called as inner transition elements. They contain two series of elements, lanthanides and actinides. 14 elements with atomic numbers 58 to 71, Ce to Lu are called as lanthanides. These elements are placed along with lanthanum La57 in the same group 3 in period 6 because of very close resemblance in properties. 14 elements with atomic numbers 90 to 103, Th to Lr, are called as actinides. These elements are placed along with actinium Ac89 in the same group 3 in period 7 because of very close resemblance in properties. Elements in the modern periodic table are classified on the basis of their electronic configuration. They are divided into 4 blocks: S block, P block, D block and F block. Groups 1 and 2 are included in S block. These elements contain 1 or 2 electrons in their outermost shell. All these elements are metals. Groups 13 to 17 and 0 group elements are included in P block. They contain 3 to 8 electrons in their outermost shell. P block contains all types of metals, that is metals, nonmetals and metalloids. Elements from S block and P block are called as normal elements. These elements have outermost shell incomplete except 0 group elements. 0 group elements have completed outermost shell. They are called as inert elements or noble elements. All these elements are gases. Groups 3 to 12 are known as D block elements. These elements have 2 outermost shells incomplete. They are known as transition elements. All these elements are metals. Elements present at the bottom of the periodic table, that is lanthanides and actinides, are called as F block elements. They have three outermost shells incomplete. They are called as inner transition elements. All these elements are metals. Now let us brush up some points related to modern periodic table. Let us try to answer the questions. Activity Question 1. Write electronic configuration of elements from atomic number 11 to 18. Answer. Electronic configuration of elements from atomic number 11 to 18 are as follows. Sodium 281, magnesium 282, aluminium 283, silicon 284, phosphorus 285, sulfur 286, chlorine 287, argon 288. Question 2. What similarities do you find in electronic configuration of elements from atomic number 11 to 18? Answer. The similarity in the electronic configuration of elements from atomic number 11 to 18 is that first two shells are complete for all elements. Question 3. How many valence electrons are present in sodium, aluminium and chlorine? Answer. In sodium, one valence electron is present. In aluminium, 3 valence electrons are present. In chlorine, 7 valence electrons are present. Question 4. Write electronic configuration of magnesium and calcium, fluorine and chlorine. Answer. Electronic configuration of magnesium is 282. Calcium is 2882. Fluorine is 27. Chlorine is 287. Question 5. Do magnesium and calcium, fluorine and chlorine contain same number of valence electrons? Answer. Yes, same number of valence electrons are seen in magnesium and calcium as well as in fluorine and chlorine. Question 6. Write electronic configuration of boron, oxygen, sodium, aluminium, sulfur and potassium. Answer. The electronic configuration of boron is 2,3. Oxygen is 2,6. Sodium is 2,8,1. Aluminium is 2,8,3. Sulfur is 2,8,6. Potassium is 2,8,8,1. Activity Question 1. Classify elements from atomic number 11 to 18 as metals or non-metals depending on the electrons present in the outermost shell. Answer. Valence electrons of first 3 elements. 1, 2 and 3 electrons are easily lost to gain octet state by atoms. Metals lose electron to form positive ions. Therefore, sodium, magnesium and aluminium are metals. Note valence electrons of remaining elements. Non-metals gain electrons to form negative ions. Therefore, silicon, phosphorus, sulfur, chlorine and argon are non-metals. Question 2. Write electronic configuration of magnesium, potassium, argon and fluorine. Answer. The electronic configuration of magnesium is 2,8,2. Potassium is 2,8,8,1. Argon is 2,8,8. Fluorine is 2,7. Activity Question 1. Select any 20 elements from all groups. Let us select 20 elements randomly. Arrange them as shown in the table. Question 2. Identify the block to which each belongs. Answer. Lithium, sodium, beryllium and magnesium belong to S block. Aluminium, boron, silicon, carbon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, neon and argon belong to P block. Manganese and iron belong to D block. Lanthanum and actinium belong to F block. Question 3. Identify to which group each element belongs. Answer. Lithium and sodium belongs to group 1. Beryllium and magnesium belong to group 2. Manganese belongs to group 7. Iron belongs to group 8. Boron and aluminium belong to group 13. Carbon and silicon belong to group 14. Nitrogen and phosphorus belong to group 15. Oxygen and sulfur belong to group 16. Fluorine and chlorine belong to group 17. Neon and argon belong to group 18. Lanthanum and actinium belong to group 3. Let us see the merits of modern periodic table over Mendeleev's table. All isotopes of the same elements have different masses but same atomic number. Therefore, they occupy the same position in the modern periodic table. For example, you can see in the table that hydrogen has one place despite having 3 isotopes. When elements are arranged according to their atomic numbers, the anomaly regarding certain pairs of elements in Mendeleev's periodic table disappears. For example, atomic number of cobalt and nickel are 27 and 28 respectively. Therefore, cobalt will come first and then nickel, although its atomic mass is greater. Elements are classified according to their electronic configuration into different blocks. Now let us try to understand what is meant by periodic properties. The properties which show gradual variation in a group and in a period and the way they repeat themselves after a certain interval of atomic number are called periodic properties. Valency. The valency of an element is determined by the number of valence electrons present in the outermost shell of an atom. All the elements of a group have the same number of valence electrons. Therefore, they have the same valency. Valency increases from 1 to 4 for the second and third period and then decreases from 4 to 0 when you go from left to right in the table. Let us look at the activity. Question 1. How do you calculate valency of an element from its electronic configuration? Answer. The valency of an element is determined by the number of valence electrons present in the outermost shell of an atom. For example, oxygen has an electronic configuration of 2,6. Valence electron is 6. Valency will be the number of electrons needed by the atom to complete its outermost shell. Here, oxygen requires 2 electrons to reach octet state, so valency is 2. In case of elements having less than 4 valence electrons, the valency is equal to the valence electron. Example, magnesium has 2 valence electrons, hence its valency is 2. Question 2. What is the valency of elements with atomic number 8, 14, 17 and 20? Answer. Valency of elements with atomic number 8, 14, 17 and 20 are 2, 4, 1 and 2 respectively. Question 3. How does valency vary in a period and in a group? Answer. 1. All the elements of a group have the same number of valence electrons. Therefore, they have the same valency. 2. Valency increases from 1 to 4 for the second and third period and then decreases from 4 to 0 when you go from left to right in the table. Atomic size. Atomic size is determined using atomic radius. For an isolated atom, atomic radius is the distance between the center of atom and the outermost shell. In a period, atomic radius generally decreases from left to right. This is because the electrons are added up to the same shell and experience greater pull from the nucleus. Atomic radius increases in a group from top to bottom as new shells are added, bringing outermost electrons farther from the nucleus. Let us try to answer some questions in this activity. Question 1. Atomic radii of third period are given here. Period 3 elements sulfur, sodium, chlorine, phosphorus, magnesium, silicon, aluminium. Their atomic radius in picometer are as follows: 127, 190, 99, 128, 160, 132, 143. A. Arrange these elements in the decreasing order of their atomic radii. Answer. We have arranged the elements in the decreasing order of their atomic radii like this: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine. B. Are they arranged as in a periodic table? Answer. Yes, they are arranged as in periodic table. C. Which is the atom of highest and lowest atomic radii? Answer. The atom of highest radii is sodium and lowest radii is chlorine. D. What trend is observed in the atomic radii in a period from left to right? Answer. We can see that atomic radii decreases from left to right in a period. Question 2. Atomic radii of group 17 are given here. Group 17 elements: iodine, fluorine, chlorine, bromine. Atomic radius in picometer are as follows: 133, 72, 99, 114. A. Arrange in increasing order of their atomic radii. Answer. We have arranged the elements in the increasing order of their atomic radii like this: fluorine, chlorine, bromine, iodine. B. Are they arranged as in the periodic table? Answer. Yes, they are arranged as in the periodic table. C. Which is the atom of highest and lowest atomic radii? Answer. The atom of highest is iodine and lowest radii are fluorine. D. What trend is observed in the atomic radii down a group? Answer. The atomic radii increases down a group. Metallic and non-metallic properties. Metals show tendency to lose electrons. Therefore, they are said to be electropositive. You can see how one electron is given out by sodium atom. Non-metals show tendency to accept electrons or share electrons with another atom. Therefore, they are said to be electronegative. You can see chlorine atom taking one electron to become electropositive. Metallic character decreases and non-metallic character increases from left to right in a period. This is because atomic size decreases. Therefore, the electrons are not easily released. Elements on the left of period are all metals and on the right are non-metals. In a group, metallic character increases and non-metallic character decreases from top to bottom. This is because atomic size increases and valence electrons can be easily removed. In group 14, first element is carbon, C, which is non-metal. Next, two elements, silicon, Si, and germanium, Ge, are metalloids, and remaining elements, tin, Sn, and lead, Pb, are metals. In modern periodic table, a zigzag line separates metals from non-metals. The borderline elements, that is boron, B, silicon, Si, germanium, Ge, arsenic, As, tellurium, Te, and polonium, Po, show intermediate properties and are called as metalloids or semi-metals.